Okay, now we're going to add some cases. So we're going to be looking at, it says, determine if the two triangles are congruent. If they are, state how you know. We have side, 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 angle, side, which we learned on Monday. Angle, side, angle, 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 side, which we learned on Tuesday. But now we're going to talk about special cases. What are special cases? Let's take a look. What if I have two triangles here and I said the three angles? The three angles are equal. Is that enough for two triangles to be the same size? Well, I know equilateral triangles. I know a triangle, let's say all sides are equal. So let's say I have a triangle that's 3, 3, 3. All equilateral triangles have angles that are 60. So all the angles are 60 as well. 60, 60, 60. That's one thing that I have on equilateral triangles. So if I have another triangle, let's say the sides were like 7, 7, 7. I know the angles are 60, 60, 60. All triangles that are equal sides, have equal angles, and it happen to be 60. So that means I can have two triangles where all three sides of one angle are equal to the three angles of when the three angles of one triangle are equal to the angles of the other triangle, does not necessarily mean that the two triangles are congruent. So I'm gonna say the rule angle, angle, angle is not sufficient. If we ever run into the case angle, 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 that thing doesn't work. So that's a special case. It might confuse us. Now there's another special case which we're going to call side-side angle. I know we can spell it backwards, side-side angle, it spells something else, but it's going to be the same rule, okay? We're going to call it side-side angle. So people might call it angle side-side. It's the same thing. Now, what this thing says is two sides of one triangle. So let's say I have these two sides. Let me come up with a triangle. Let's say it's side, side, and then there's an angle. Let's say I have this side 5, 7, and 30 degrees. And I tell myself, okay, let me create the other triangle 5. And let's say 7 and 30 degrees. Well, that thing doesn't quite work, right? That thing doesn't quite work. Hmm. So, so matter of fact, let me check something really quick. Let me show you guys through my program here, Sketchpad. Let me show you guys real quick. Okay, let's say we had a limit of side angle. So these two sides that I'm going to highlight, those two sides are not going to change. I could rotate them, but the side is going to be the same thing. What if I had the limit that those two sides cannot change and this angle cannot change? I have it 38.33, just the angle. So that means the third side, I don't care about the third side. I'm just saying the two sides that I said are not going to change and that angle is not going to change. Can I possibly become Can I possibly create two different triangles with that limitation? The dotted line, as big as I want it, because I have no limit on that. It's just the two solid lines cannot change and the angle cannot change. Can I possibly come with two different triangles? And I'm gonna say, well, there's one triangle. Well, how about there? There's a different triangle. Notice how my two sides that I said, the two solid lines did not change and that angle did not change. So for side angle, I had that thing that I didn't care. I didn't care about the dotted line, but the limits that I came out with, side angle, I was able to come out with two different triangles. So side angle doesn't work. There is one time when it does work. Let's say, well, what if I'm gonna change this things right here. I'm gonna change my angle to 90 degrees. Again, the dotted line, I don't care, as big as I want it to be. It's just that this side and this other side are not gonna change. Again, I can rotate them. That angle is not gonna change. Can I possibly come with two different triangles? Well, I happen to touch it about right there. I come out with a triangle. And then some people might be like, if I move it up, it's not a triangle anymore because it doesn't touch the side. But if I move it down, it doesn't touch the side again. It does happen. It does happen again on this other side. When I change this down here, somewhere about there, I'm not going to quite get it at 90 degrees, but somewhere around there, people might say, oh, I get another triangle with the same limitation, but in reality, the same triangle. It just got flipped. It got reflected. So I'm gonna say side angle does not work unless it's a 90-degree angle. But then we're not gonna call it side angle. We're gonna call it HL, hypotenuse leg. Remember how you learned back in the days when the angle was 90 degrees, the biggest side was a hypotenuse and the other sides were called legs? So we're gonna call it hypotenuse leg. So let me come back to our notes here. We're looking at questions 29 through 30. So looking at here, the special cases, angle does not work. Side angle does not work unless it's a 90 degrees. So big key, side angle as it is, it doesn't work unless it's a 90-degree angle, but then we're going to call it HL, hypotenuse leg. All right, let's take a look at our example here, number 29. I can mark this side. Actually, let me mark it in red. I can mark this side. It's not given, but it is shared by both triangles. And here it is asking, determine if the two triangles are congruent. And if they are, state how you know. Well, one triangle. What do I see on one triangle? I'm going to focus on the triangle. When I'm looking at this, honestly, I always look at two of something. Either two sides or two angles are marked. Well, I see two sides. So this is what I do. Two sides. And then I ask myself, is the angle in between the sides? Yeah, this one is in between the sides because it is the included angle. Remember, included angle, when we talk about included angles, when the angle is where the two sides meet, that's what we call included angle. So this is side. Two sides and the angle in between. Is the other one marked the same way? Yes. So side. Just because you saw 90-degree angle doesn't mean it has to be HL. Sometimes I'm going to confuse you like that. Take a look at number 30. These two angles I can mark because vertical angle theorem. I see this triangle here. Two of something. Two angles or two sides. In this case, I see two angles. Is the side in between the angles? In between will be right there. Is the side in between the angles? No. So I'm going to put it like right there. Not in between. A as a rule? Yeah, angle side, right? Is the other triangle marked the same way? Yes. So this is angle side. If you call it side angle, you're good to go as well. You can write it one way or the other. Okay, let me flip the page. Let's take a look at number 31. Determine whether the triangles are congruent. If they are, state how you know. I'm marking in the same way. So here, I'm saying this side is equal to this side, and this side is equal to this side, and then there's an angle given. So I look at the triangle on the left. Ooh, two sides and the angle is not in between. So side angle. Is that the same thing I have on the other side? Well, not really, right? The two sides are not equal. So this case is not congruent. Now, what if I had gone like this? Yeah, that one would be congruent, not side angle. That one would have been HL. Okay, let's take a look at number 32. This side is equal to this side. This side, the second side is equal to this one. And this third side is equal to this third side. Three sides of one triangle are equal to three sides of the other. Side. Pretty cool. And then I know the part that we kind of don't like sometimes, but we got to do this though. State what additional information is required in order to know that triangles are congruent for the reason given. And we have side angle side, angle side, special cases. Remember for special cases, angle never works. HL is basically side angle. But in that case, angle is 90 degrees. So let's see. Indirectly, I can say this angle is equal to this angle. Vertical angle theorem allows me to do that. I want this to be angle side. So two sides and the included angle. So from one triangle, I'm going to need this side. And from the other triangle, I'm going to need this side. So side SM is equal to side ML. Remember, for sides, I use two letters. Now let's take a look at number 34. I can say this angle is equal to this angle. I want this to be angle side. So two angles and a side, but the side is not included. So the side is not in between the angles. So I'm looking at that triangle on the left, and I first start thinking, can I mark this angle? No, because then the side will be between the angles. Okay, so in that case, no. I'm gonna mark this angle, and on this other triangle, I ask myself, can I mark this angle? No, because the sides will be between the angles. Okay, in that case, I'm gonna mark this other angle. I have two angles in the side, but the side not in between the angles. Remember, for angles, I'm gonna try to use the three letters of that triangle. So looking at this triangle, I'm gonna use all three letters, W in the center. So I'm gonna call this UWZ equals. For the other triangle, I'm going to use all three letters with B in the center. So I can call this DBC. Sometimes the short way, the lazy way, one letter works. In this case, it would have worked. I would have said angle W is equal to angle B. It would have worked. However, if there are multiple corners, multiple angles at one corner, then the lazy way does not work. Try to get used to the long way, the three letters. That one always works. The lazy way sometimes works, but if there are multiple angles at one corner, and remember we talk about that. Let's say I have a corner A, but I have three corners there, three angles. Because I could be thinking of this angle, or this angle, then the lazy way does not work. So there are multiple angles at one corner, lazy way does not work.